now. So over to you, Stephen.
Can you see my screen okay?
Yes, I can see it.
Super, excellent. All right, let's get started. Let me just bring up the correct window and let's start. Hello, everyone. Welcome to this Impact Lab event by the Environmental Futures and Big Data Impact Lab, situated in Exeter. My name is Stephen Haddad, and I'm a scientific software engineer at the Met Office Informatics Lab, which is one of the partners in the Impact Lab project. And so today I'll be going through some material about climate data primarily, and thinking about how you can easily make use of the climate data that's available to start thinking about kind of the impact of climate change on your business and incorporating that into future business plans. So the material I'll be presenting today is available. I'll post this link in the chat in a moment on this GitHub repository here. So if you want to see any of the material afterwards, it's all available there with example code for you to go through. And we will send out that information afterwards in an email as well for people. So you don't have to be frantically writing anything down during the event. So let's get started. What are we going to be talking about? In this tutorial, we're going to be done in 3 sections. The first section will sort of introduce climate change and climate data sets. In part 2, we'll think a bit about climate impacts, how climate change impacts individuals and businesses. And there might be some audience participation in this point, so get ready to answer the odd question. And then in section 3, we will look at some example code of how to extract relevant climate data to do some analysis on climate impacts for particular business cases. So first of all, let's look at some terminology. So first of all, you might already be aware of this, but it's just important to highlight what is the difference between weather and climate. They're both talking about meteorological variables such as temperature, humidity, wind and rain and so on. So why do we have 2 separate terms? So it's all about different timescales. Weather describes the conditions of the atmosphere at a particular instant or hourly or daily for things such as temperature, rainfall, etc. Whereas climate, on the other hand, is the long-term average of these variables. One quite nice way of putting it, said by Robert Heinlein, was climate is what you expect, weather is what you get. Or perhaps even more simply, weather is how you choose your outfit, climate is how you choose your wardrobe. I think that's quite a nice illustration of the difference between weather and climate. And there's some links on here about some various Met Office videos and other materials looking at weather and climate in more detail, so do feel free to read those later. But we're interested in the moment in kind of weather and climate data. So what data might there be? So for example, weather data might be the current air temperature and humidity at a particular location or over a whole region, the amount of rain that fell in the past 12 hours, current wind speed and direction, the maximum gust of wind in the last hour, or the total energy in terms of solar radiation recorded on your roof today, for example. Climate, on the other hand, we said is the long-term averages of those variables. So rather than the current air temperature, say the average maximum air temperature for a particular location for a particular month of the year. So for example, what is the average maximum temperature for Exeter in the UK for March, which I think is 12 degrees. The average number of days with precipitation greater than a certain amount. That's telling us something about, on average, how many days of substantial rain falls every year or month. The average wind speed over a whole month, telling us how windy a particular month is, or the prevailing wind direction, or the average daily solar radiation for a particular month and location. So those are all climatic variables versus weather variables. So that's what climate is. So what then is climate change? Well, there's natural variability both in weather and climate. As I'm sure you're living in the UK, one doesn't need to tell anyone that weather varies greatly day to day. But there's also changes in the climate over various short terms. There's patterns in the climate. Some years are warmer, some years are colder. Some sections of years are warmer or colder as well. So there is variability in our climate system. For a variety of reasons, we have changes in solar activity or volcanic eruptions or various other patterns which bring about changes, but they can also be the result of human activities such as emissions of greenhouse gases or changes in land use from, say, a forest to arable land. And since the Ice Age ended about 11,000 years ago, actually our climate's been relatively stable. In fact, there's an average global temperature of 14 degrees. However, in the 20th century and the 21st century, we have seen a warming of that global temperature. And here we have a Met-Office data set called HAD-CRU-T5, which shows average global temperatures relative to the 1961 to 1990 averages. And we can see how global temperatures have gone up. So the different colors here are different data sets, which vary in different ways about how they put the temperature together, but we see they generally agree about this warming trend. So that's global warming, and it's expected that global warming will lead to changes in our climate, and that global warming is due to human emissions of greenhouse gases. So that's at the highest level how our climate is changing. The average global temperature is increasing. But climate change is much more than just that global increase in average temperature. And the effects of the increases in carbon dioxide, as well as global temperatures, can mean a variety of things. So changes to global patterns in the circulation of the atmosphere, which means changing weather patterns. Increases in the temperature of the ocean and acidification of the ocean. And complicated and varies changes then to local weather patterns. So in order to study climate change, we need lots of data to understand how that climate change is going to affect individuals, businesses, or organizations in a particular area. So let's introduce some climate data sets that we can use to study climate change and its impacts. So in order to understand past, present, and future climate, the Met Office and many other climate organizations and researchers around the world gather and produce lots of data sets. And in general, for the starting point for research is to take some measurements, and climate science is no different. And as the slides, the notebook says here, the Met Office has been a data-driven organization and a user of big data well before either of those were fashionable terms. So the first sort of data that we use is observational data sets, come from a variety of different locations and have a variety of different sorts of measurements. So the most obvious sort of weather measurement that you might be familiar with, it comes from a weather station on the ground with a thermometer and a rain gauge and an anemometer and a wind vane and so on. So those are ground stations, and the Met Office has a whole network of weather stations. You can see on this page over here how our weather stations are distributed across the UK, measuring different variables. And so we have quite a lot of very old data sets. So there's a data set called the Central England Temperature Record, or CET, which measures temperature records going all the way back to 1659. And you can see here is a plot of that temperature record over time, again, similarly showing a warming trend over time. But that's a very old temperature record just for a particular location. But over time, we've increased the number of stations, as you saw in that image, and there are weather stations all over the world. And traditionally, countries share their data from ground stations through the World Meteorological Organization. So since the 1960s and the advent of artificial satellites orbiting the Earth, very quickly we started using those to take pictures of the Earth and in particular to monitor weather and climate, which is particularly useful because you get a comprehensive view over the whole Earth with a satellite view. So even where an area that is sparsely populated, such as over the oceans or in cold areas or deserts, you can still get measurements from a satellite. And so, for example, I'm sure you're familiar with the sort of data you get from that. Here is data from EU METSAT, which is a European satellite weather satellite organization that the Met Office participates in. And so here's the current satellite picture over Europe. And so over the long term, you can measure all sorts of variables through satellites. And just from information purposes, not that it's particularly useful for your business planning, but we also look at studying the climate going further back than we have measurements, using indirect measurements, which are quite interesting, I think, using things like ice cores and isotopes of certain elements, tree growth rings, all sorts of proxies for measurements of climate variables like temperature and levels of carbon dioxide in the atmosphere. So this is an area of study called paleoclimate, which is very interesting, but not particularly relevant for small business planning. So we'll move right on from that. So those are all observational data sets that we can use in terms of planning. So we'll often get combined together into a single climate data set using ground stations and satellite measurements and all sorts of measurements into a single sort of grid covering the whole Earth at regular intervals, covering either the UK or the whole Earth. So, for example, the Met Office produces that data set called HADCRET 5. We looked at a particular global average of the global average temperature produced by that, but you can get it at a grid covering the whole Earth, and indeed other organizations such as ECMWF, is the European Centre for Medium Range Weather Forecast, can you hear me again, Anna?
Yes.
Ah, super, thank you. Sorry about that. I have no idea what my computer was doing there. Let me share my screen again. Super. So I think you lost me at the point where I was introducing some climate data. So here we're going to have a look at what's called a reanalysis data set, where they combine all those different sorts of climate measurements with in a physically consistent way. So this is called the ERA 5 data produced by ECMWF. And so you can easily load this. It's freely available. In this case, I'm accessing the version that's stored on AWS S3. And you can access it easily through Python over here. So I'm loading a particular month's worth of data, particular variables. So air temperature at 2 meters. That's a traditional way of measuring temperature. And so this is essentially weather data, because it's taken every hour. And we can see, so for example, at a particular time, it has 720 by 1440 points. And so here is a temperature around the globe at a particular point, which is freely available. So this is the sort of data we can use to understand what was happening in the past climate, either all over the world at a particular time, or we can also extract for a particular location. And look at a particular time series over, in this case, a month. So that's a temperature over a particular month. Where was this location? 45 degrees, north 180 degrees. That's somewhere in the northern Pacific Ocean. And so we have that data freely available. But in addition to measurements, we also have climate simulations, because, well, climate measurements are very useful. They tell us about what's happened in the past of the climate. But in order to do planning for business, we want to know what we think might happen to our climate in the future. So obviously we don't have observations from the future. So we have to simulate our climate system of the Earth in order to make some predictions. And the Met Office and many other organizations have developed sophisticated physics-based simulation software to simulate the climate of the Earth and predict its future state. So the climate and the atmosphere is a chaotic system, so small changes in the initial state of your simulation can become big changes later on. So you run several simulations to see multiple possible outcomes for the future climate. So this is called an ensemble of simulations. Now this is a very expensive undertaking, in both in terms of creating the simulations, but also running them. It's computationally expensive, requiring a powerful supercomputer. So typically, organizations run this and then share the data, and there's lots of other people use in their research of various sorts, or planning for governments and businesses and so on. So two higher profile climate simulation datasets include what's called CMIP6, or formerly Climate Model Intercomparison Project, 6th phase, which is a global climate simulation project where different organizations all around the world run climate simulations and share them. And then the one that the Met Office has done, which is the UK Climate Projections 2018, or UKCP, which is then focused on much higher resolution simulations of the climate, but only for the UK. And that's what we'll be focusing on today, using those climate simulations from the UK to look at impacts on individuals and business. So how can you get these data sets? Well, they're generally freely available. CMIP6 data is also available on AWS. And it's a huge data set. You can see here, I'm using something called an intake catalog, which lists all the data available in a data set. So it's actually, this phone's stored on Google Cloud, but that's not particularly important. And so you can see 36 different institutions, organizations like the Met Office have produced many different data sets around the future climate. So there's lots and lots of data we can use from these simulations to understand how the climate might change and often change in different scenarios. So the climate simulations will simulate what happens if we emit a certain amount of greenhouse gases, or what happens if we cut greenhouse gases down to zero, or what happens if we're emitting twice as many greenhouse gases in the future as we are now. What will the effect on our climate be? So that's what running lots of different climate simulations can tell us. And so you can look at these notebooks later on how you can access this data very easily. It's quite fun to play around with, see what different scenarios show. And similarly, you can plot data for the whole world, for a particular time, from a particular data set. So this is temperature from the German weather service and their climate forecasts. And similarly, you can plot a time series. So for example, I've compared two time series for average monthly temperature for Cape Town, where I'm from, on the left, and for Exeter on the right. And you can see gradually a sort of gradual upward trend between 2015 and 2100, which is when this particular data set runs. So that's a global climate temperature data set. But what's really valuable is bringing climate change down to a more local level. And that's what UKCP is all about, much higher resolution simulations of the climate. So here, this data, you generally need to download it from a place called CEDAR, which there's a link to somewhere on this notebook. And then you download it, and then you can load the data and see what you get. So for example, here I'm loading the temperature forecast for 2039. So this is just one of the possible forecasts, because it's one member in our ensemble, as we mentioned. And so you can see I've got 600 by 400, by 500 points for each time step, and I've got 360 time steps, because in climate data we make things easier for ourselves by pretending that the year has 360 days in it, which doesn't actually make any difference to long-term climate averages. But yeah. Just to say, if you've got any questions as you go along, please don't hesitate to put them in the chat, and I can answer them as we go along. And I'll pause for questions between sections as well, if you want to ask vocally. Yes, so here again, we can plot a particular location. So for example, here I'm calculating seasonal averages for the year 2039 across the UK. And so you can see how temperature varies in that summer, presumably autumn, winter, spring. Sure that's right. Oh no, sorry, I've got that wrong. So that's winter, spring, summer, autumn. Just my color scale makes it look different. So we can easily calculate seasonal averages, which is in a climate variable from our climate simulations that are freely available. And so we can do different things. So this is air temperature. Here is the time series for a particular location. So here is for this particular ensemble member, for this year, the forecast temperature in forecast daily maximum temperatures in Exeter for this ensemble member. So all this data is freely available. We're going to be looking at 4 particular variables today. Air temperature, one of them, but so that's daily average maximum air temperature, daily minimum air temperature. We're also going to be looking at average daily wind speed at the surface, and also average incoming solar radiation at the surface, and we'll see why those are of interest to us. So that's our climate data that we're going to work with. Let's move on to what this means in terms of impacts. So before I do that, do you have any questions anyone would like to ask at this stage? As I said, if you do anything does come to mind, feel free to enter questions in the chat, and I can deal with those during the talk or at the end, depending on what's appropriate. But let's move on now to climate impacts. So we've looked at changes in climate, how the global temperature is warming, how we see warming trends in individual locations when we look at climate simulations. But what does this actually mean for businesses and individuals? What are the impacts of climate change? And so here's quite a useful diagram. Actually, let me try and zoom out a little. Oh, it's unfortunate. A useful diagram of impacts. So in the middle of this diagram is the things that are driving climate change. So in this case, greenhouse gas emissions, emissions of other aerosols into the atmosphere, changes in land use, all these things affect our climate in the long term. And then the way that happens is that they affect the climate system, and they affect it in a variety of ways. So the oceans warm, ice melts, sea levels rise, changes in weather patterns, more frequent extreme weather patterns. Those are all changes to climate variables in our climate system. But that ultimately impacts people through the outer circle, which is the impacts circle. And how might these changes to the climate system impact humans? So, for example, we have from increases in extremes of wet and dryness, we have risk to water supplies, risk to food. From increase in frequency of extreme weather, we have damage to infrastructure. This insecurity and damage might lead to conflict and climate migrants, greater flooding, both from extreme rainfall events or from due to sea level rises. Damage again to our marine ecosystems and fisheries might again exacerbate food insecurity. Those are all different ways in which changes to the climate system actually then impact on the world, in particular on individuals and businesses. And so looking at that data that we looked at previously, there's some nice tools which are available to start drilling down into what that data means on a local level. So this, for example, is created by the BBC based on Met-Office data, where you can enter your postcode and then see what will be changing about the weather in your climate in your area in the future. So that's quite a nice way to get started looking at this climate data. There's a link in the notebook for you to play around with that. So how might we start thinking about the impact on particular businesses? So at this point, I just wanted to stop and had some thoughts. How do you people think that climate change might impact on a small business? Any thoughts? If you have any thoughts, if you don't have any thoughts, that's fine, we'll move on. But if you have any thoughts, feel free to speak up. Well, if you have any thoughts, feel free to enter them in the chat on the Zoom call, and we can look at those in a moment. But for the meantime, let's think about some examples that I've come up with. So, for example, Some of the impacts come from the need to reduce greenhouse gas emissions, that is, reduce the drivers of climate change in this diagram over here. So, for example, small businesses might take into account changes to energy supplies for buildings, and indeed the way we supply energy might also be affected by climate change, we'll see in a moment. Changes to how transportation works and is the energy used, changes to how people travel for business and leisure might affect small businesses, and changes to how people commute or work from home due to energy requirements and the effect that might have on, say, office space. There's some interesting links here where people go into more details about a whole variety of ways in which climate change can impact on small business. And that makes for an interesting read to think about that. But today we're going to look at using that climate data and think about how we might start using climate data to analyze particular questions that would be of interest in business planning. So you can see there's a sort of model here of how that might happen. We've got climate observations and simulations. Maybe you may have some business outcomes data about particular profitability of certain investments or something similar, which you can bring together with climate data. And then you generally want to have some sort of model of how to bring that data together to predict a business impact of climate change. So in our example that I'll be showing in a moment, we'll be looking at two particular things. One is about energy generation. So what is the impact on solar power generating capacity from climate change? So this, you might be wanting to install some solar panels on the roof of your business to reduce your energy costs. Well, how is that investment and your return on investment in terms of the power generated going to be affected by climate change? Are you going to be able to generate more energy or less energy? Our model there is basically, it's quite a simple model. We're saying that with increased solar radiation basically the changes in solar radiation will result in proportional changes in generating capacity. So that's one thing we'll look at now, how we can analyze that from our data. Similarly, wind power, so our impact model there is our change in generating capacity for wind power is proportional to average wind speed. So we'll see what the average wind speed data has to say about how an investment, the return on investment on investing in wind power capacity might change in the future. The leisure and hospitality industry, how might changes in leisure and hospitality temperature affect leisure and hospitality businesses? For example, somewhere like down here in the southwest of England, where tourism is important in the economy, might climate change mean better or worse conditions for small hospitality businesses? And we'll look at our model there is basically saying that maybe an increase in temperature provides more kind of outdoor leisure activity, so it's better for business. But conversely, there might also be, with higher minimum temperatures, buildings don't naturally cool themselves down at night, so there might be increased expense required for active cooling in the form of air conditions for those hospitality businesses. So two different sort of models of impact from the same set of climate data. So we'll now move on to looking at how we can actually get some answers there from our climate data. Any questions on what we did in that section? Okay, so now we're going to be looking at using some very standard Python packages. So this is one of the easiest ways to do this sort of data science work. Using those standard data sets we've looked at so far to explore what the climate data says about our particular business impact questions. So we're using standard libraries in Python for those who are interested, the pandas library for handling tabular data, the X-array and iris libraries for importing and processing the climate data in an array, gridded array format. And lib, and seaborn for plotting our data, so we can visually analyze what the data says and what this means for our business impacts. So now one thing, if you start playing around with weather and climate data, you'll quickly discover is that the data sets are really big, so they can be quite cumbersome and slow to work with at times when you're trying to do really large scale analysis. So we've done some reduction of the data sets, myself and my colleague Maria, who's worked with me and produced these notebooks with me, to reduce the data sets to something more manageable. And so it's going to quickly demonstrate how one does that from the raw data for a particular subset of it. So I've downloaded the data from the server onto AWS S3. So it's all ready to go. And so we're looking at the UKCP dataset, the 2.2 kilometer resolution simulations, the latest version, which was published then. And these are our ensemble members. There's 12 members of our ensemble, instead looking at different possible future climates. So if we want to extract data for some particular sites and for particular variables that are of interest to our business. So here we've got some sites. Where's my list of sites gone? Oh, it's further down. So we're interested in extracting average daily solar radiation, so average surface wind speed, daily maximum surface temperature, and daily minimum surface temperature. And we've extracted them at these sites: Exeter, Cambridge, Manchester, Newcastle, and Edinburgh in the UK. And we're looking at 3 eras of time: the climate in 1980 to 2000, 2020 to 2040, that's sort of present, and then in the future, 2060 to 2080, and see how those variables at those sites differ. So in order to produce that data set, for each of the sites, for each of the years, you load a gridded data set. So you can see over here, we've got 600 by about 500 points for the whole UK. And then you select a particular place. So for example, Exeter. As you can see, this is what a particular possible climate forecast for Exeter is for 2039-40. And then, so that's for a particular, this is for then not for a particular member of the ensemble, but we've now taken the average, as you can see over here, across all of them. This gives us a more robust signal, combining those different possible future climates together into a single prediction. And so we've done this for all those sites. So you can see in more detail if you're interested in how that's done, if you want to do this yourself in the future in this notebook. But this makes it much easier for analysis for particular sites, but generally if you're a business, you're interested in particular locations and the climate impacts in those local areas. So our first case was solar energy. So you can see some solar panels on a roof, quite a lot of solar panels on some roofs. I think this is in Germany. So how might climate change affect generation of solar panels at different sites? So here, for example, we have a plot of the average daily solar radiation for different sites. Red is blue is Exeter, yellow is Newcastle, Manchester, and Edinburgh. I should label those. And so we can see over time, you can see how in the 1980 to 2000 period where we start, solar radiation at all sites is generally lower than at the end of the period. So in the 2060 to 2080 period over here, you can see how this changed. So for example, Exeter in 2060 to 2080 is roughly the same capacity as Cambridge was in 1980 to 2000. So we can see how that all changed. So let's look at a particular site though and see how that changed in more detail. So here we have monthly averages of solar radiation at the surface for Exeter for each of our 3 eras. So era 1 is 1980 to 2000, era 2, 2020 to 2040, and era 3, 2060 to 2080. And so we can see here some particular trends for this site. We can see how actually in sort of winter, January, February, December, there's not much change in solar radiation. It's pretty dull and will continue to be. But in summer, June, July, August, we can see in each of those 3 months, total solar radiation is well up in the era 3 compared to era 2 and era 1. So there'll be a noticeable increase in solar radiation. So actually you'll have an improvement in your return on your investment going forward for installing solar panels at a site in Exeter, for example. So climate data translates into impacts that way as a return on solar investment, which you can then incorporate into deciding whether it's cost effective for you to install solar panels. And so we can look down at some more data and we can see how these changes affect other sites. So for example, here we compare a table of data comparing era 1 and era 3 for our 5 sites in the different months. So we can see, so for example, in July, there's July across all our sites there, and there's July across all our sites there. We see across the board our solar radiation is higher in July in era 3 compared to era 1. And that's shown again in these 2 plots, comparing era 1 on the left and era 3 on the right for all the months. Much the same in winter, but noticeably up in summer for all our sites. So that's something you can incorporate into business planning. And to present that information a different way, you can see here we've used the Seaborn plotting library to create a nice distribution of in terms of the output of so the solar radiation at a site in terms of number of days in which you have that level of solar radiation, so giving us a sort of pseudo probability distribution. So for winter, spring, summer, autumn, we can see how that distribution doesn't really change very much in winter in terms of the number of days of different levels of solar radiation. There's a very clear shift from the blue, which is era 1, orange is era 2, green is era 3. That curve is shifted to the right, which is shifting towards higher levels of radiation. So clear signal of greater solar radiation in summer. So that's solar radiation. What about other variables? For example, wind power. Will wind power be affected by climate change, and will it be affected positively or negatively? So let's have a look at a similar plot for average surface wind speed. And here we see a different sort of signal. Actually, we see more or less the same amount of wind at all our sites in year 1, 2, and 3. Even potentially maybe a slight decrease, but that's probably just noise. At statistically significant levels, we can say it's about the same. And if we look at our plots over here, again, for a particular site, say, for example, Manchester, we see those curves move a little bit, but they're not greatly different in any of our seasons. So wind doesn't look like, average surface wind doesn't look like it'll be greatly affected by climate change, according to these projections. And therefore we can say, based on our impact model, the impact on wind generation will not be substantial from climate change. We expect that to kind of continue having the same amount of return on investment in terms of energy capacity, generating capacity. So that's wind. What about some temperature related impacts? So what might our impact model be here? Just we might say higher maximums might mean maybe it's more popular to go to the beach and other outdoor leisure centers in areas that maybe were previously too cool, or maybe at times of year that were previously too cool for certain activities. With increase in temperatures, maximum temperatures in the sort of shoulder seasons, you have an extended season for tourism, so investing in some sort of tourist facility might give you greater return on investment. But it might also mean that there's greater chance of heat stress with increase in temperatures for people, including your employees. What about higher minimums? This also, you have different impacts from higher minimums. So again, maybe hospitality industry in the evening can make greater use of outdoor space. But an important one in terms of impact from higher minimum temperatures is that buildings may not cool down as effectively in summer. So you might need to invest in artificial cooling, air conditioning, and that has great further expense in running that cooling, which is perhaps a negative impact of climate change. So how might we do that? So we get our data from our tables using pandas for particular locations. So you might say, well, how might the number of days greater than 15 degrees or 20 degrees or 23 degrees be affected for a particular location? Because those, you might decide that those are days that are popular for certain leisure activities. Let's see how that will be affected. So we can see if your activity is affected, you decide your threshold is 15 degrees maximum. We can see that, well, okay, in summer that's kind of normal for Exeter, so kind of maxed out already in summer, but there are far more days greater than 15 degrees at the edge of the season. So in this case, early in April and late in October, November, in year 3, 2060 to 2080, compared to 1980 to 2000. So greater season for a leisure activity where the temperature needs to be greater than 15 degrees for people to want to do that. And similarly, you can see perhaps for quite warm weather activities. So you start, well, this is for something greater than 23 degrees, whereas in our climate simulations for era 1 and era 2, there were very few, if any, days projected to be greater than 23 degrees. We see there's quite substantial numbers of days greater than 23 degrees in this scenario for the future climate for Exeter. So leisure facilities that might not have done very well in this location in the past might do very well in the future. So that could be something to incorporate in investment plans for a business in the future. So that's average maximum temperatures. What about average minimum temperatures? Similarly, you come up with some sort of threshold. Maybe if nighttime temperatures are greater than 10 degrees, you don't need any heating or something similar. So you can see you won't need any heating for a larger period of the year in this scenario. Similarly, though, if nighttime temperatures are greater than 14 or 16 degrees, it might be absolutely essential to have some sort of cooling available to keep your guests comfortable. And so you see that whereas days above with minimum didn't really happen in era 1 and only occasionally in era 2, era 3 we see these are quite common. So investments in cooling will be important for these scenarios. And so again, you can see looking at these parts of distribution. So for example, let's look at our Newcastle site. We can see in all 4 seasons in terms of average maximum daily temperature, there's a shift of our distribution curve to the right towards warmer temperatures in all 4 seasons. So that's a very clear signal. So that's some basic example of how you can use some readily available data and readily available Python libraries to start exploring what climate data says about climate change for you, in your location, for your business, and to think about what that might mean in terms of future planning. So what might the next steps be? What this has hopefully been an interesting seminar, but what might you be able to do with that information? Well, you might want to think about what areas of your business do you think might be expected by climate change? And you might think what climate variables might affect this area of your business? And then how do you translate climate variables like temperature or wind or precipitation into a business impact? Is this something you already know, the relationship? We speculated on some of the relationships here that we already know. Might you have to learn it? So you can use climate machine learning or statistical analysis to learn that relationship and develop that model. And then where can you get the data that you need, both in terms of the business data and the climate data? And once you've answered those questions, you can start thinking about how climate change might affect your business. And that's it for today. I hope that's been interesting. Do you have any questions?
I might want to kick off the questions.
Great,
Thanks for that, Stephen. That was great and very informative. You've talked or touched on temperature, wind, and sunshine, and I was thinking, how about rainfall? I mean, I want to believe that even if not for small businesses, that could go a long way in maybe determining how you generate electricity in places like in Africa, where you don't have a lot of wind, so you can do a lot of wind generation. If there's a lot of rainfall, then maybe you might decide that you want to go into hydro generation in the future. So I was just thinking how rainfall comes in here.
Yeah. So well, so for example, the solar radiation figure that, where's that gone to? Sure, this is using a climate simulation that includes all weather sorts. So this will be taking that into account, changes in rainfall and how it have, hold on, I'm in the right place. Sorry. Yes, so this is taking into account that. We haven't looked at rainfall variables just because analysis of rainfall tends to be more complicated because rainfall can vary quite substantially over a very small area. It can be raining buckets right here and a kilometer away. It's completely different. So that makes analysis of it often quite a bit more complicated. So just for being able to fit in the session into an hour, I didn't talk too much about rainfall, but both all the climate data sets I mentioned in terms of measurements and climate simulations include rainfall as a variable because it's very important in terms of impacts like food security and water security. So a lot of people are very interested in changes to rainfall in terms of being a high impact one. But as I said, kind of understanding that impact can be a bit more complicated. So that kind of impacts model here tends to be a bit more complicated, so harder to explain in an hour.
Yeah, thanks for that. That makes a lot of sense. I mean, we know that one of the stories that we hear, unfortunate things that happen during this global warming is a lot of flooding around, and maybe that is a bit caused by rainfall as well. So yeah, I feel it's something important. But yeah, as far as those features are already in here, and we know that we can always do that if we wanted to consider what we could do in terms of, like you said, food security and water supply and stuff. That's important. So thanks.
So yes, you're welcome to use these notebooks, and you can, so where I've used particular variables like temperature, you can get the rainfall variable and see what the analysis shows for that. Certainly it's very topical at the moment. I mean, if you compare, say for example, Australia, last year, sort of this time last year, they were just recovering from drought and wildfires, and now they're having epic heavy rainfall in similar sort of areas. So it's extremes at both ends that are of interest in the climate change studies.
Thanks, Stephen.
Sorry.
Maria, go ahead.
Just to add to Ola's question, about the UK CP18, the very high resolution climate data, 2.2 kilometers, are only for the UK, unfortunately. So one of the good features of that is that they have much reduced bias about precipitation. So they are, because of the high resolution and the way they were run. But it is, so you can do, actually it was developed the best set to use for flooding or extreme events, anything related with precipitation. But unfortunately, it is only for the UK. So, and I don't know much about the other climate data about rain. So probably they suffer from the normal biases and things.
Yeah.
So for other parts, yeah.
Stephen, can I ask, how does the resolution or granularity vary region by region, maybe country by country? I mean, in the UK, are we looking generally at kilometre squares? And then how does that compare with elsewhere?
Yes. So this UKCP data, UK climate predictions data, as Maria just said, it's 2 by 2 kilometre squares over the UK. So that's very high resolution for climate simulations that are running for a long period of time.
Yeah.
So that's why it's kind of a step change in the kind of fidelity of these simulations for the UK, because it can incorporate kind of convective weather systems in the climate projections. For this, I mentioned CMIP6, which is a global temperature data set. So comparatively, that's much larger grid squares for these typically. Higher resolution simulations in this data set are maybe 10 kilometers at best, but mostly it's tens of kilometers per grid square. So I mean, this one that I'm plotting over here, I think I showed the resolution somewhere. That's about sort of say 300 by 200 or something squares covering the whole world.
Yeah.
So obviously you're going to have much less incorporation of local variability and local weather patterns into such a sort of coarse resolution. Simulation is much more looking at kind of global weather patterns.
But the trend, I take it, globally is for greater resolution, increasingly good resolution.
That's right, exactly. So people run these simulations as at a higher resolution as they can afford to do so.
Yeah. Good, thank you.
No problem. Anything to
If
add,
I can
Maria?
add something to that.
Please do.
From the climate models, yes, it is, the resolution is coarse, but then that's why for various impacts, sometimes people use downscaling, which uses statistical and these days machine learning to come from a very coarse grid down to a finer resolution, preserving, if you like, trying to preserve the trends in wind or with the variables, the weather variables, that's all, because of the expense of running climate models in. Yeah.
Okay. Yeah, that makes sense.
So yeah, you almost a bit sort of starting to move into this kind of model where you have your sort of simulation, then you have some sort of additional model to bring it down to a local climate variable kind of level.
Or you use different climate models also to create like an ensemble to constrain the uncertainty, if you like.
Yeah. Any other questions? Well, as I said, we'll send out an email with the link to these notebooks. Hopefully you can have a chance to kind of play around with them and see. It's quite fun to see what the climate projections show and what what's contained in the data. Kind of ask your own questions of it. And it's very easy to do these days with the standard kind of Python tools. So I recommend having a play. And if you have any other questions, don't hesitate to get in touch via email. But otherwise, I think we'll end it there.
Brilliant. Thank you very much, Stephen. And thank you very much to everyone else for attending today. Like Stephen said, I'll send out an email. I'll also include the link to this recording just so that you can do a sort of step-by-step tutorial, if you will. In the meantime, have a lovely afternoon, morning or evening, depending where you are. And yeah, hope to see you again soon. Bye.
Thank you.
Thank you. That was excellent.